Greetings, Mr. Wahlberg here, talking to you about density. Talking about matter and measurement with you guys, understanding how we measure things in science. One of the big topics and understanding we need to have is about density. And by definition, you should write this down: how close particles are to each other in a substance. We have a picture there of, I would guess something like a piece of cork floating in water. Piece of wood, which is actually denser than cork. It is still floating in water. And then, of course, something made out of metal is going to sink all the way to the bottom of water. And that's exactly, water is always a great judge of density. You take something like a tree, cut it down, it would float in the river. You take a tiny little pebble, a rock, and you throw it in the water, and it would sink. So even though that tree would weigh more than the rock, that tree is less dense than the rock. I cheated. I'd like you to draw a couple of pictures of different densities. As I said, I cheated. You can't do this in your notebook, but I'd like you to draw two different substances, two different densities. Something like this would be the piece of wood. Something like this would be, the rock. They have different densities of each other because their particles are spaced out differently.
Today, I'm going to show you a simple science experiment that you can try at home to measure density. Start by taking an empty glass and tip in some water and food coloring. Then add some syrup or treacle. And I'm going to add a little bit more water to make the layer a bit thicker. Then finally, fill the glass up with some oil and leave it to settle for about 15 minutes. These liquids are very happy to do different levels because they're different densities altogether. A syrup has a high density, so it sits on the bottom. The oil is actually the density. Right at the top, try dropping different objects to see what happens. If we drop this like a plastic, which is very dense, we see it sitting right at the bottom. But if I take this rainbow, it sees the water and sits on top. This means the syrup is actually
All right, I don't expect you to do that. It was just a neat, fun example of what I'm talking about. We go from the bottom, metal, most dense, and then the syrup. The grape sits on top of that with water. On top of the water is the bottle cap, and then we've got oil on top of that, and then a piece of sponge on top of that. Again, showing you differences in density of objects. There is some math when it comes to density, and we're going to be doing a little bit of that. We're going to divide mass divided by volume. So you should write that down. The formula for density is mass divided by volume. There are two different labels. We talked about the difference in labels for volume. Well, there are two different labels for density depending on what the volume was measured in. We can divide grams per milliliter, or we can divide grams per centimeter cubed. Again, depending on what the volume was measured in. And again, they are equal to each other. Doesn't matter which label you use, they are going to be different. They're just going to be labeled differently. Again, another diagram, understanding different objects have different densities. A couple of practice problems for you to submit on Schoology after you watch this. A rock has a mass of 6.2 grams. There's your mass. You're going to divide by the volume of 2.1 milliliters, and you're going to find the density of the rock. Your label will be grams per milliliter. So solve for that, and that's number one. Number two, density of an object has a mass of 5 grams, volume of 50 centimeters cubed. Again, divide mass divided by volume. So submit both of those answers, and we'll go over those tomorrow and do some more practice problems. Hope you followed along and understand a little more about density. We've got some things still to work on, though. Have a great night. We'll see you tomorrow.